Hello, good afternoon, everyone. Thank you for attending today's webinar. Pardon my voice and pauses because I caught a bit of cold, so it may sound a bit different. But anyways, so thank you again for joining today's session. Today's session is more on our EnGenius Wi-Fi 6 stations. So for those who are not aware, we actually have another line of products that's focused on point-to-point and point-to-multipoint deployments. So these are the N stations, ENS series, ENH series, and so on. So last webinar that we had, I introduced a couple, which is the ENH 500AX as well as the N Station 6. So I'll talk about more in detail in terms of the applications, what are the benefits versus the previous generation of bridges that we had, and so on. But this will be a short webinar. If you guys have any questions, as usual, you can type it on the Q&A or on the chat or using the Q&A function in Zoom. And this webinar would be recorded and it will be uploaded on our YouTube page as well, which is engenius.apac. So let's proceed. So as I mentioned, last webinar that we had when we introduced new products that we are launching for EnGenius this year, we announced a couple of new stations. So that's the N Station 6 as well as the ENH 500AX. So what does this mean? What does these models bring? Because we have in the past we had the N Station AC, N Station 5, ENH 500, if you're familiar with those. So these are the bridges that we've been using for the longest time. So with Wi-Fi 6, so we're bringing this to the point-to-point solution as well. Essentially, it brings the same technology that we have with our indoor products. One major advantage is the change to, or the shift to OFDMA. With OFDMA, if you are in the past using multiple different applications, running multiple packets, maybe you're running videos, you're running data at the same time on the background, on OFDM it runs a bit slower. I would say there would be a bit more headroom for the AP to process that, and then you would experience high latency, especially if you add video in the mix. With the OFDMA, even if you have this different applications mixed in, running on the same network, same VLAN, there shouldn't be any issue in terms of your throughput. So what this means is, if you have a point-to-point setup, let's say maybe you're sharing internet access, or you're using it for wireless surveillance, or other types of applications, you would have less latency and smoother results in terms of the transmission. So even if you have multiple connections, multiple apps at the same time running over this wireless bridge, you should still have a stable connection, as if you're using a cable plugged in. The modulation have increased as well. Of course, it boosts this a lot as compared to the previous generation. This essentially is why you can have more throughput as compared to Wi-Fi 5 or even before that. The throughput is boosted to roughly about 40% in terms of the actual results. Later on, I can show you a bit of tests that our R&D team did in Taiwan, so you can see the difference in terms of the throughput values. When it comes to MU-MIMO, of course, Wi-Fi 6 is also capable of doing so. So that means that in point-to-multipoint scenarios, let's say you're using EnGenius bridges, EnGenius stations, paired with maybe EnGenius outdoor base stations, like the cloud base stations or the EnGenius Fit base stations, Wi-Fi 6. So you can have all those connected simultaneously without really affecting each other. And of course, you can still have that throughput depending on how many bridges you have linked to your main access point. So for the hardware, as a recap of what I showed last week, we have the ENH 500AX. This is the Wi-Fi 6 2x2 access point. So it's fixed mounting, meaning you can mount it on the wall or on a pole, and it's going to be fixed on a fixed position. So alignment must be done pre-deployment so that you can have a good RSSI level or signal quality later on. It's capable to have 1200 Mbps data rate, and then internally it has a built-in internal patch antenna, which is 16 dBi. It's high power, and then it has dual LAN ports as well. So it has dual LAN ports, so you can use one to power up the device and provide data. Second LAN port can be used to connect another IP device. Let's say, for example, an IP camera going down to your network and so on. So later I'll show some examples. Excuse me. So effective range of this access point is up to about 8 kilometers or 5 miles. So at that range, you can still get over 100 Mbps of actual throughput. So as compared to the previous generation, ENH500 version 3 or EndStation AC and Station 5 AC, you get about 40% faster actual throughput with this device. We also have a counterpart with the EndStation series, which is the EndStation 6. So the EndStation 6, roughly about the same specs, a bit of difference in the antenna gain because of the antenna design, but this is more for same types of deployment, point to point, but it gives you a lot more flexibility in terms of alignment, because the EndStation 6 has a rotatable front face, meaning even if you mount it on the wall or on a pole, you can still do proper adjustments after mounting the device. So if, let's say, you're deploying this in a pack and go scenario, maybe you're deploying Wi-Fi access temporarily for a concert event, outdoor wireless venue, maybe you're hosting a wedding or something, and you just want to provide temporary Wi-Fi access, which you'll take down after a couple of days. So it's easy to work with the EndStation 6 because you can easily align the AP point where the base station is, or if it's like a construction. So some of our clients are into that type of application. They have, for instance, IP surveillance scattered on the construction site. If they want to move or focus to another area of that construction site, if let's say the first part is already done, then they can just easily realign the bridges or the stations. So same with the ENH500, it also comes with dual LAN ports, can be powered up through PoE. At the same time, connect to another device for the secondary LAN connection. So what are the applications that we usually use for bridges? Maybe if you have been an EnGenius user in the past, you're already familiar with this. For those who are new, we usually use point-to-point and point-to-multipoint scenario commonly for outdoor surveillance. So let's say, for instance, you have your NVR on on the HQ side. So maybe this is the local government or local municipality, local police station that want to monitor certain sites, maybe exit and entry points or traffic stops and all that. Usually for surveillance, you would need to have it wired. Maybe you need to have it running through fiber. But if you're deploying for, let's say, a 1 kilometer radius, 3 kilometers or more than that, it's going to be difficult to lay all those cables. It might even be a lot costly as well. You're going to have to access permits and all that. If you convert that to wireless instead, then it can save you a lot of time as well as cost in the deployment. So here, one sample scenario, again, you have your NVR. Let's say this is HQ. Goes to the router, goes to the switch, and then you have your injector. Comes with a package as well. The injector going to the EndStation. So here the EndStation 6 is powered up through this PoE injector. At the same time, the other port there goes through the NVR to send data back and forth. Now, let's say on the opposite end, maybe 500 meters away or 2 kilometers away, there is a traffic stop that you want to monitor. So there you have another EndStation. So it's pointing directly towards the first one that you have, and then on the second LAN port you have your IP camera, and then on the first LAN port goes down to the PoE injector for power as well. So here it's as if you have these two devices wired together to get that video feed from your wireless camera. Usually IP cameras, maybe HD cam, would run in about 5 to 8 Mbps. If it's a 4K IP camera, roughly about 25 Mbps maybe, depending on your presets, FPS, quality, bitrate and all that. But maybe 25 Mbps is already generous. With the capacity of the EndStation 6 or ENH500, there's a lot of headroom there for your throughput. You can have multiple IP cameras here, maybe linked to a switch before going back to the EndStation to serve multiple 4K video feeds as well on a specific area. Another type of scenario, which is pretty common as well, is in providing outdoor hotspot deployment. Let's say in parks, outdoor resorts, maybe. Let's say the poolside, the beachside, or like I mentioned earlier, temporary events where you need a quick deployment and you can just stick it out after a couple of days. So in that scenario, what is shared here is the internet data. So let's say from one of the poles or one of the towers or one of the sources of your internet connection, you have an end station or ENH 500, and then point to point to another device, which may be any of our bridges as well. So this bridge right here would receive the data and then go to the LAN port of your access point. So any access point that we have, maybe ECW access point for the cloud, or EWS 850 FIT for our FIT series. So from there, this base station or access point can then rebroadcast the internet traffic for the client connection. So it makes it a lot easier because you don't have to run a wire from, let's say, your ISP source going there to the park. It also saves you, again, from having to lay out a lot of cables. If this is a resort, definitely you wouldn't be able to like hang cables around or have someone bury the cables underneath. That's going to be costly for your end user. So converting that to a wireless setup can be a lot easier. Like I mentioned, with Wi-Fi 6 you can have mixed applications as well. So even if the guests here are doing video traffic, downloading, maybe transferring emails and so on and so forth, your internet link should be pretty much stable as well. It's as if you just have a wired link there. So this is a pretty common setup, and it's a lot easier again to move this around. So let's say you want to move this base station to somewhere else, or maybe you want to extend the connection further. Maybe you want to add another bridge and then link to another base station, or from here you want to have a mesh setup, mesh scenario. So base station mesh to another base station and so on and so forth, so you can have a bigger coverage. Of course, for your point-to-point link, you still have a good bandwidth that you have for the Wi-Fi 6 connection. So some of the throughput results that was gathered to us from HQ, let me just run over them. So here, first test is a 1 kilometer throughput test in one of the cities or provinces in Taiwan. So from there, they tested 3 different scenarios. First one is by using 20 megahertz channel width. This one is on the ENH 500AX. And then second test is running 40 megahertz, and then third test is 80 megahertz. So channel width means your channel scope or channel frequency. The smaller it is, the less interference. The bigger channel width is, the more channel coverage you would take over in terms of your frequency range. That could mean more interference as well, but if you're working on a clean line of sight scenario with little to less interference, you can have the fastest data rate possible for your bridge. So here, 1 kilometer point to point, 20 megahertz channel with actual throughput is about 180 Mbps. So this is a combination of transmit and receive packets. 40 megahertz, that increased it to 320 Mbps, and then 80 megahertz, they got about 650 Mbps. So imagine if you're doing internet bridging. Maybe you want to share your internet connection from one branch to another branch if you have line of sight, or maybe you want to access or you want to share the same database, the same storage for, let's say, multiple warehouses that you want to link together. So instead of wiring them up, you can just set up wireless point-to-point bridges to quickly transfer data back and forth with the speed at 1 kilometer. So moving farther at 3 kilometers, so same equipment, same type of test, point-to-point, access point to client bridge mode. Again, 20 megahertz, 40 megahertz, and 80 megahertz test. This can easily be tweaked, by the way, on the access point user interface, which I'll show in a while. So 20 megahertz, they were able to get about 127 Mbps throughput, 40, 249 Mbps, and then when they max out the radio, they can get about 471 Mbps at 3 kilometers. So looking at the RSSI level, it's still pretty good, negative 63. It's as good as you're just connected near your home router. That's the equivalent of this RSSI result. RSSI, by the way, this means this is your signal strength between the radio. So if I have a pair of access points, point to point, this is my signal quality in between. Just a reminder. So this was tested in um, a controlled environment, meaning they had to make sure that there's little to less to no noise in this area. I'm not sure if they checked the whole path, but essentially it's going across the river, so there's less interference there. If you're having the same type of deployment in a city scenario, maybe you would have higher RSSI here or less throughput because of interference. So that can easily be adjusted by either lowering your channel width or switching to a different channel. So quick comparison between the ENH 500AX Wi-Fi 6 radio as well as the ENH 500 version 3, which is running Wi-Fi 5 or 802.11ac Wave 2. So here are the throughput results. First column is the attenuation, meaning the added overhead, which can reduce your RSSI or signal quality between your points. This is the second column is the ENH 500AX. Third column is the older generation. So at maximum range, at the lowest range possible, the closest signal or the best signal or best RSSI you can get if you're close to the access point. This is the throughput. So this is all in Mbps. If you're using the Wi-Fi 6 radio, you can get about 932 Mbps. For the Wi-Fi 5 AP, then it's about 647 Mbps. Of course, if you go further, if you add more attenuation, the signal could mean that it's dropping or you're getting further away from the AP. So the farther that you get away, this would be the equivalent throughput that you would get. So ENH 500 here, version 3, caps out at about 135 Mbps before dropping once they add more attenuation, while the ENH 500AX still can go even further. So this means if, for example, you have a deployment running ENH 500 version 3 in the past, maybe you set it up at 5 kilometers or 8 kilometers or even more than that. Let's say you stretch it at 10. If at 10 kilometers you were getting like 100 Mbps or even lower than that, with the Wi-Fi 6 ENH 500AX, maybe you can get about 200, double that, or more, depending on the conditions. So let me do a quick walkthrough of the user interface. I was supposed to show you the Wi-Fi app because these stations are also compatible with that, but they are still tweaking something on the application to fully support these models. But the N Station 6 as well as the ENH 500AX are compatible with N-Wi-Fi. That means that you can easily use an application to configure and monitor your connection. You can monitor your throughput, you can do some tests, you can do the firmware upgrade directly from the N-Wi-Fi app as well without having to connect a laptop and run it through. It also has built-in tests that you can run, like speed tests, ping tests, and so on. But for now, let me show you the user interface through a browser. Just a minute. Okay, so hopefully my browser is visible. So here I have a live ENH 500AX that's deployed here at my home network. Let me connect to it. So you would see a familiar interface if you are used to using our stations and bridges. I just updated this yesterday, which is why the uptime is refreshed. But I had this running for, I believe, about almost a month now, with very stable results. So right now I connected this unit to another EnGenius access point, an EnGenius Fit AP, which is the 357 Fit. Later on I'll show you the details, but I'm connected using channel 36. For Wi-Fi, we've noticed that the lower the channel for 5 gig, the faster the throughput you could get. So this is why I set it to channel 36. You can see that my data rate is at 1201 Mbps, and then noise level is slightly low, not high, but is okay. Signal strength is about average as well. So my access point, the EWS 357 Fit, is actually about 10 meters away, and there's like 3 partitions between this bridge and that device. So I'm still getting the highest data rate from there. On the wireless side, we have a bit of changes here on the user interface. So previously, you'd have, sorry, please ignore this repeater option. Previously, we have options here that would show you like an access point station, and then you would have WDS station, WDS bridge, WDS client bridge, and so on. So now you have this operating modes. So first is access point mode. If you want this to be broadcasting your connection, same with our other units, you can broadcast multiple SSIDs, or you can set it up as a station or client bridge, as we usually call it. So the client bridge would connect to an access point to establish the connection. Basically, the access point would throw the data that you need. The station is the receiver. We also have WDS here, which is now a toggleable option. WDS means wireless distribution system. What this does is it allows you to connect multiple APs or multiple access points. But in the case of station mode, if you are using WDS, that means that would make your MAC address transparent. To elaborate further, for example, you have an access point and then you have a station. So this station, maybe you connect it to a PC, you connect it to a switch with multiple other devices connecting there. So assuming you would have multiple devices, that means you have multiple MAC addresses running on your station side. Wait, let me go back to the presentation a while so you can easily visualize. So let's say this point right here. Am I sharing the right screen? Yeah. So let's say this point right here is your station. This point right here is your station. This is your access point. So without WDS, if my wireless client sends any packet out on the system, this side right here on the network side would only see the MAC address of this particular bridge. It would not see the MAC address of the clients. It's not visible at all. So anything that goes back and forth, I would only see the MAC of my station. That's fine in some scenarios, but in other scenarios that can cause an issue. If let's say you are connecting this device to wireless cameras and you have multiple, and then you have your NVR right here, your NVR may not detect your IP cameras if it reads it through their MAC addresses because it's not visible. If you enable WDS, then that would make the connection transparent. Then your NVR would be able to see all the MAC addresses that are coming out from this device. So that means if you have multiple cameras there, it would then be fully visible to this site. So not all brands offer WDS, but this is a good addition on EnGenius side so that you can have your connection transparent. So for the rest of the options, is pretty much similar. So here I mentioned that I'm connected to the EnGenius Fit, so you can verify that by going to device discovery. This one uses LLDP from the access point, so it will auto detect all EnGenius devices that are in the same network. So here I have my EWS 357 Fit. Basically I'm using this as the access point, and then my bridge is my ENH500AX. Again, connection with about 3 to 4 partitions 10 meters away. I can still get the full data rate of 1200 Mbps. In terms of the setup, whether you're using the portal or if you're using the N-Wi-Fi app, it's pretty simple. So if let's say this is your station, you want to connect to an existing access point, all you need to do is click on scan, and then from there your AP would scan the vicinity, and then you would be able to select an access point to connect to. Let me just check if it can do that right now. I forgot this is my actual internet source as well. Hopefully it doesn't go down. So yeah, these are the detected SSIDs. If you want to connect to one of them, you just have to click on them. If you are using your station mode, and then fill in the SSID. The SSID would be filled in once you click on it. Select the security mode and then apply. That's it. So this also supports WPA3 as well. So once you apply, then you can verify your connection under the Connections tab. For the advanced functions, this also supports SNMP if you want to do third-party monitoring. It supports CLI access as well if you want to configure it from CLI. It also has a Wi-Fi scheduler if you set this up as an access point, or if you want it to auto reboot, you can do so as well. Right now I have it all disabled. For the tool side, these are the same tools that are available under N Wi-Fi. So you have your ping test, you have your trace route, NS lookup, speed test, and again device discovery. So when using the speed test, take note that this would use the CPU of the device, so your results may be lower than the actual throughput. So what we usually do when doing speed test is to use iPerf or any third-party device. So I would have a PC on one end, and then my bridge, and then on the opposite end of the bridge I have another PC to run the speed test. So in that method, I can fully check the bandwidth running on the bridge without having to sacrifice processing on my bridge in terms of the CPU usage. So apart from that, you can set up your firmware right here, logs and all that. Firmware upgrade, if you're using the portal, is manual. That means you have to get it from the website. But if you're using the Wi-Fi app, it automatically checks the firmware from the server, and then from there you can push the firmware update. So technically it's a lot easier when you're using the Wi-Fi app in terms of configuration, because this you can also use the you can also use the management interface on this device. So I think I didn't mention yet, but this device is a 5 GHz Wi-Fi 6 device. So that means it only has 5 GHz for your bridge, but it has a second radio for management, for linking to the app or your laptop, which runs in 2.4. So this you can enable or disable anytime. So that means if you are close to the device, within range, you can connect to it and configure it from there. Using the Wi-Fi app, you just have to connect to this customizable SSID as well. So yeah, for the bridge, everything would pass through. If you have multiple VLANs, that would pass through your bridge as well. Okay, so do you guys have any questions? Let me just go over the chat here if there are. Okay, question here regarding the power source. You mentioned that the bridge can be powered up by PoE. Is that AF or AT? Furthermore, does the hardware include a PoE injector or adapter? So yeah, the bridges, in terms of the actual power source, we have it listed out on the datasheet, but we also include the actual PoE injector in the package as well. Specifically, what's included is the EPA 5006GR. So this is a great PoE injector because it has a reset button on the injector itself. So if, for example, your access point is mounted on a tower or a high enough pole, if you want to reset the device, all you need to do is do the reset from your injector, which can be from the console down below. So it makes it a lot easier in terms of management and troubleshooting. So the injector also has two LAN ports. So one to power up the AP, the other port goes to your network. What is the beam width of the bridge units? If I'm not mistaken, both units have a beam width of about 30 to 40 degrees. So that's horizontal and vertical. So it's slim or narrow to make it more focused. So a more focused beam means a higher throughput. But to get the exact beam width, I believe we have the antenna diagram on the data sheets as well. Another question here: are the base stations managed by the cloud or via NSky EasyMaster only? So for our base stations like the ECW or EWS, so that those are either on-prem or EasyMaster managed, you can link our bridges to any of those base stations. But if you are asking about the N-Station 6 and the NH500 specifically, these are more of standalone units, which you would control either through accessing the portal or through the N-Wi-Fi app. You won't be able to manage it using the cloud, but we do have plans to have bridges in the future. I just can't give the full information right now. Good question here. What type of weather conditions will affect the outer bridge and performance? For example, stormy, heavy rain, and so on and so forth. I think I didn't mention IP rating. So IP rating of the devices are IP55. Correct me if I'm wrong, Nancy. So these devices can withstand heavy rain, heavy or high temperatures like what we're experiencing right now, or heavy monsoons as well. So in the package you would have rubber enclosures or gaskets that you can use on the LAN ports to further protect the device. But in terms of the performance, let's say you have a point-to-point link. If the rain is super heavy, so long as you have your connection there, it really wouldn't affect it that much. If there's a reduction in your throughput or your RSSI level, maybe it's less than 5%, and so on. What I would worry about when deploying over a body of water is deploying over a body of water, because when it's very hot, that body of water can turn into water vapor and can act like a sheet of glass, which can block your connection. So this can disrupt your connection to maybe about 10 or 20%. It depends on the environment, but usually heavy rains, so long as it does not topple the device or dislodge the alignment of the unit, there shouldn't be any issue. How long is the point-to-point range for the devices? So both these devices have a recommended range of about 8 kilometers, but of course you can go lower or farther depending on your setup and depending on the bandwidth that you require. Another question is, do you have any point-to-point product that supports 2.4 gigahertz? In the past, we did have 2.4 gigahertz point-to-point products, but this new set of line for Wi-Fi 6 are only 5 gigahertz. Does the end station solution have a path or link simulator, example the height of the tower on both ends, and so on and so forth? We have the Easy Wi-Fi Planner. You can select our end station or ENH products from there, but it doesn't simulate the height itself. So if you want to simulate the height, I would advise you use third-party software, something like Google Earth, to measure the height of the land to check if you have line of sight between your products. Okay, so let me go to chat. I think chat has questions as well. How many receiver can support with one station and point to multipoint? Does it support 360 degrees broadcast signal? So first question, how many receivers does it support? So if you have an access point and then you have a station set to WDS or just a normal station connected, it can support a lot. In the past, if you're going to do WDS, the limit is about 8 on our previous units. So in this new generation of devices, it's not limited by that, so you can go over 8. It would depend then on how much bandwidth you want to supply per station. Also, since the beam width of these devices are narrow, about 30 to 40 degrees, your point to multipoint setup would be also limited by your coverage or your angle as well. So usually when we're deploying point to multipoint, we pair the bridges with outdoor APs or outdoor base station that does 360 degrees coverage. Again, for example, let's say the ECW 260 or the ECW 270, which would be able to handle more clients. So out of the box, those devices have external antennas that are included in the package, which runs at 360 degrees. So if you have that as your base station and then you connect multiple end stations or ENH 500s across the radius of that device, then you would be able to connect then. Another question is, do you guys have plans to develop 60 gigahertz products? As of now, we are still using the normal Wi-Fi frequency ranges, which is 5 gigahertz, and for 6E in the future, if we're going to release one, up to 7 gigahertz as well. But we don't have, I didn't see any plan yet for 60 gigahertz, but if we have that in production, we'll let you know as well. Can the device stand? Can the device? Oh, okay. I think the question here is, can I install the device near the sea? Because as we know, if you're deploying near the sea, the air would be salty. So this can cause the device to have their PCBs corrode and all that, and it may damage your unit. So the ENH500AX and N-Station 6 are both IP rated, IP55. So that means even if you deploy this in harsh environments, it should be able to withstand it. In the package, it has this rubber or foam gaskets that you can cover on the land ports to further protect the unit from water. But if you're deploying near the sea, I would suggest to increase the security of those ports. Maybe you can add silicone gel around it to prevent salt water from or salty air from getting in and out of the device. But apart from the land ports, the rest of the device is properly enclosed. So, like for example, the N-Station 6, the whole unit, the face of it is vacuum sealed, so no air can go in the unit or the device. So yeah, it's pretty safe to deploy in the sea area. Let's say you're deploying this for resorts or other beach areas as well. By the way, the mounting kit for pole mount as well as wall mount are included as well in the package. Apart from the injector, that's also included as well. So essentially, out of the box, you would be able to deploy the unit. I think all you're gonna need is the cable to run from your injector to the unit and back to your network, and that's it. But the rest are in the package already. Okay, thank you, Nancy, for sharing the datasheet. So we have the datasheet up as well on our website for both N-Station 6 as well as ENH500AX, as well as all the rest of the products that we have discussed on the previous webinar. Okay, guys. Do you have any other questions? By the way, if you want to pair the N-Station or ENH500AX to our base stations, it can be any base station. Even if the base station is managed by, let's say, the cloud for ECW series, or FIT for ENH 8, EWS 850 FIT. So it's cross compatible. You can work on those bridges even if you have those access points already set up. So essentially, if you are linking a network using this bridge, all you need to do is set it up using WDS station, find the SSID, select it, and then key in your password for that SSID, and that's it. Your connection would be established. The only difficult part in setting up a wireless link is essentially the alignment. So once you have your alignment zoned in, then you can have the connection. But apart from that, the rest is pretty straightforward. Okay, another question here. Is it possible to use point-to-point crossing block buildings in the sites we want to install? So usually when we deploy point-to-point or point-to-multipoint, we would advise the client to have a clean line of sight, meaning from both your bridges, let's say end station A to end station B, we recommend to have a clean path. You may have a bit of obstructions, but this would greatly affect your connections. Let's say you have a tree in between, you have leaves, or you have a billboard in between. I would avoid that. I would either raise my end stations higher, maybe higher a bit through extending the pole further, or I can go over it, or I can create a relay if, let's say, I'm deploying on a mountain. But apart from that, yeah, we would always suggest to have a clean line of sight, because that could greatly impact your throughput. Sorry, one more thing I want to show, just a while. Because earlier I saw a map, a sample of a point-to-multipoint deployment. I just want to share this with you guys as well. Okay, so in this scenario, let me try to enhance this. Let's use paint. Okay, so here's a sample setup in using a point-to-point and point-to-multipoint scenario with relays as well. Sorry, I can get the zoom right. Can you guys see? Hopefully. Yeah, so again, here's a sample scenario. We have a point-to-point and point-to-multipoint setup with several relays to spread internet connection across a camp. So here is the source of your internet connection. This would be your base station. You would have your main point-to-point links here. This is your ISP internet source. So from here you have several end stations connected to it. One of them connected to the access point, like my sample a while ago. You can have an access point linked to your base station, and then from there you would spread your internet access. So all the clients right here connect to that access point, and then the data goes back to the bridge, back to HQ. So similar with other sites. So for example, you have non-line of sight. Let's say, for example, from this camp going back to HQ, let's say there's no direct line of sight. Maybe because here in between you have a trees blocking or some buildings blocking. So one way to go over that is, again, elevate the sites. If it's already high enough or you can't extend further up, then you can create a relay. So the relay here is like this site right here. Sorry. So here I have a relay which essentially goes around that obstacle or the obstruction to have your connection back. So basically here you have a point link from HQ or for internet source going to one bridge, and then maybe you have an access point here just to share internet access to this area, and then it's connected to another bridge which would then relay the connection from HQ back to this spot where I want my connection. So this is another way to go over an obstacle. You can have multiple relays, but just check your again, interference, your latency. If it's so far, or if you have multiple relays, then that can affect your connections. But we have some clients who have deployed quite a number of relays before providing internet access to their spot. I think one of the guys set up like 5 to 6 relays. So all those relays were powered by solar, and then they have backup battery to provide internet access across a mountainous terrain. So from the city, they had 5 relays, something like this, back to back, and then go over or pointing to the last site, the last mile, which provided internet access to one of the schools, or which didn't have internet access. So setting something up like that is maybe difficult, but the end result is very satisfying, especially for your end users who will get that connection. Transmitting angle or beam width roughly about 30 to 40 degrees, but you can verify that information as well for the exact number on our datasheet as well. So yeah, if no more questions, again, this webinar is recorded, so if you miss out the first part, you can go later on to our YouTube APAC page, EnGenius APAC, to check the recording. Apart from that, thank you again for attending today's webinar. We'll announce what the next webinar's topics are through EnGenius Academy and through our regional sales team as well. So thank you everyone for attending today's session. You guys have a wonderful day. Bye bye.